Here we are on page 7 of logic. Let P and Q be the statements P is less than 36 and X is equal to 36. Express in words P or Q and P exclusive or Q. Okay, so let's do A1 first. So P or Q would be X is less than 36, X is less than 36, or X is equal to 36. And then 2 would be, one thing. X is equal to 36, or X is equal to 36, or both. Or X is less than and equal to 36. And then 2 would be X is less than 36 or equal to 36, but not both. Okay, and then it says the statement X is less than or equal to 36 is equivalent to the first part of part A or the second part of part A? Which one? So I would say it has to be equal to 2 because in 2 it says but not both. Because X cannot be both equal to 36 and less than 36 at the same time. Okay? Does that make sense? When you say less than or equal to 36, which is this symbol here, what you're actually saying is less than 36 or it's equal to 36, but not both. Okay? All right. Let's go on to number 3. Let P and Q and R be statements about the set of positive integers that are less than or equal to 36. Okay, integers less than or equal to 36. So that would be 1, 2, 3, all the way to 36. P says X is a multiple of 6, which would be 6, 12, 18. Q says X is a factor of 6, which would be 1, 6, 4, 9, 12, etc. R says X is a square number. Express in terms of P, Q, and R is appropriate. Okay, number 1. Either X is a multiple of 6 or X is a factor of 6. So multiple of 6, so that's statement P. Or X is a factor of 36, which is statement Q. So it's either one, so we'll put or. Number 2. Either X is a multiple of 6 or X is a factor of 6, but not both. So that's the same thing as before, except for now it's exclusive or because it can't be both. Number 3. Either X is a multiple of 6 or X is a square number. So it's P or R. 4. Either X is a factor of 36 or X is a square number, but not both. So factor of 36 is Q. And R is X's square number, but not both, so it would be exclusive or. Number 5. Either X is a multiple of 6, which is P, or X is a factor of 36, which is Q, or X is a square number, which is R. And it says or, so we'll just put or. Last one. Either X is a multiple of 6, which is P, or X is a factor of 36, which would be Q, and X is not a square number. X is not a square number. Okay, so this is a little tricky. So we'll say and X is not a square number. So that would be X is not a square number. It would be not R. Last detail. We would like to do this operation first. Okay, so we put parentheses around it, just like we do with PEMDAS. Okay, moving on to B. List the integers X that satisfy the statements in A that make the statements above X true. Okay, so let's see, we're going to have what makes P or Q true? Which number? Let's see, X is a multiple of 6 or X is a factor of 36. So this could be either a multiple of 6 or the factors of 36. So you would have to list first the multiples of 6, which would be, and they want us to list all the ones that make it true. So it would be 6, 12, 18, 24, 30, and 36. Those are the possible multiples of 6. And then we also need to list all the factors of 36. So that would be 1, 2, 3, 4, not 5. 6 has already been listed. Not 7, not 8, 9, 10, not 10, 11. 12's already been listed. Not 13, not 14, not 15, not 16, not 17, 18's already been listed. So 1, the thing that makes this true would be any multiple of 6 or any factor of 36. So that's the list for that one. The next one is P exclusive or Q. So numbers that are in one list or the other but not both. So that means 6 is in both lists, so we're not going to list 6. 12 is in both lists, so we're not going to list 12. 18 is in both lists, so we're not going to list 18. So 24 satisfies P, but not Q. And 30 satisfies P, but not Q. And I think those are the two that satisfy P, but not Q. Now the ones that satisfy Q, but not P would be the ones that are listed here. 1, 2, 3, 4, 9. Okay? Let's see. The next one would be P or R. P or R. So x is a multiple of 6 or x is a square number. So x is a multiple of 6 would be 6, 12, 18, 24, 30, 36. And then R would be the square numbers. So it would be 1, 4, 9, 16, 25, and 36 we already wrote down, right? And then Q exclusive or R would be factors of 36 or square number, but not both, okay? So let's see, the factors of 36 would be 1, but that's a square, so we take it out. It could be 2, could be 3, 4, but that's a square, so we take it out. 5, 6, 7, 8, 9, but that's a square, so we take it out. 10, 11, 12, 13, 14, 15, 16, 17, 18, okay, or 36, but that's a square, so we take it out. And then we put in the squares that are not factors of 36, so not 1, not 4, not 9, we could put 16, and 25, okay, and not 36, okay? Now we go back to either x is a multiple of 6, or x is a factor of 36, or x is a square number, so any one of those. Wow, that's like a lot of numbers here, so that would be P or Q or R. So that would be, let's see, it would be 1, it would be 2, it would be 3, it would be 4, not 5, 6, not 7, not 8, 9, not 10, not 11, 12, not 13, not 14, not 15, 16, not 17, 18, not 19, not 20, not 21, not 22, 24, 25, and then 30, and 36. Let's see if we got them all. Do we have all the squares? 1, 4, 9, 16, 25, 36. Yeah. Do we have all the factors of 36? We have 1, we have 2, we have 4, we have 3, we have 6, we have 9, we have 12, we have 18, we have 36. Yeah. And then do we have multiples of 6? We have 6, we have 12, we have 18, we have 24, 30, and 36. Yeah, so I think we're fine there. Okay, so let's draw there. Okay. Last one. Either x is a multiple of 6 or x is a factor of 36, but x is not a square number. Okay, so we can list all the numbers we had here. All the numbers we had here. And the only thing that we're going to eliminate is now we do not want r and r. Okay, so we're gonna eliminate the numbers that are squares. So we eliminate 4, we eliminate 1, we eliminate 9, 16, and 25, and 36. And that's what we're left with there. How's that? Okay? So that was the last one there. Number 5, the propositions P and Q are defined as below. P, you have understood this topic. Q, you will be able to do this question. Express in terms of P and Q. Sentence A, you have understood this topic, or you will not be able to do this question. So P, you have understood this topic, or you will not be able to do this question. So not Q. Not Q. Next one, you have not understood this topic, so not P, and you will not be able to do this question. You will not be able to do this question, and you will not be able to do this question. Not be able to do this question. Okay. 6. Two propositions P and Q are defined as follows, where x is an element of the set of integers. P, x ends in 0. Q, x is not divisible by 5. So express in words. P is P or Q. So x is A. X ends in 0. Or x is not divisible by 5. Okay, next one is x ends in 0, or x is not divisible by 5, but not both. C, P and Q. So x ends in 0, and x is not divisible by 5. D. P and not Q. So x ends in 0, and x is not divisible by 5. Or we say x is divisible by 5. E. X does not end in 0, and x is not divisible by 5. Okay? So that are the translation words for those. Okay, 7. Consider these logic statements. P, I am studying French. Q, I am studying Chinese. Express in terms of P and Q. I am studying French, and I am studying Chinese. So that would be P and Q. I am studying French, or I am studying Chinese, but not both. So that would be exclusive or. P exclusive or Q. I am studying French or I am studying Chinese. P or Q. I am not studying French or I am not studying Chinese. I am not studying French or I am not studying Chinese. Okay, that was that one. 5. I am not studying either French or Chinese. I am not studying either French or Chinese. So that would be not French or Chinese. I am not studying both French and Chinese. So that would be I am not studying French and Chinese. Last one. I am not studying French and I am not studying Chinese. So I am not studying French and I am not studying Chinese. Now we're going to get asked several questions about which one of these statements makes these true. And so we're going to start by, I'm going to write down all the possibilities here. So for example, I am studying French and I am studying Chinese. That means that you are studying both French and Chinese. And that's all there is to it, right? There's no other possibilities. What about number 2? I am studying French or I am studying Chinese, but not both. So then there's a case that it's French only, or there's the case that it's Chinese only. But there's no other possibilities. There's no French, Chinese both, and there's not no French, no Chinese. Okay. Number 3, I am studying French or I am studying Chinese, and it could be both. So I'm going to put that it's French, it's Chinese, or it's both French, Chinese, right? And what about number 5? I am not studying French or I am not studying Chinese. So he could be studying French and he could be studying Chinese. But he couldn't be studying both because he's either not studying one or not studying the other. It could be nothing too. So there's French, Chinese, or I'll put like an empty set sign. And then 5, I am not studying either French or Chinese. So that means that he's not studying anything, right? Because if he's not studying either French or Chinese, then that means that there's nothing. I am not studying both French and Chinese, but maybe studying one or the other. I'm not studying both, so it could be French, could be Chinese, could be the empty set too, right? I am not studying French and I am not studying Chinese. Okay, so that definitely means the empty set. There's only the empty set as a possibility. Okay, so now, number 1, it is necessarily true that I'm studying both languages. So which one is the one where there's only both languages and that's all there is to it? So that would be number 1, right? 1. It may be true that I'm studying both languages. So where do you see FC, but you also see others? I see it here, and that's it. So that would be 3, right? 3. Okay, and then it is necessarily true that I am studying neither of the two languages. Neither of the two languages. Neither of the two languages would be the empty set symbol. So that would be this one, or it would be that one, or it would be that one. Oh, but they say necessarily true. So like the necessarily true one would just be that one or this one, right? So that would be 5 or 7. Okay. It may be true that I'm studying neither of the two languages. So that would be the cases where we have the empty set but with other possibilities. So that would be those two. It would be 4 or 6. 4 or 6. Okay? And so that is the end of this page.